y prime is equal to 1 over negative x plus x e to the negative x. But then you have to multiply by the derivative of the inside. The derivative of the inside, so that's going to be y prime is equal to, what's the derivative of the inside? Negative e to the negative x plus 1 e to the derivative of the first times the second plus the first times the derivative of the second all over, well, that thing, right? Can you simplify that a little bit? Sure, but is that the derivative? Are there any remaining derivatives we have to calculate to find the final derivative? No. Okay, what about this one? It's going to be 1 over times the derivative of ln x. So that's going to be 1 over ln x times 1 over. So that's equal to 1 over x ln x. That's it. That's it. Again, what's that rule? If y equals log base a of x, then two things. A to the y equals x, and what was that thing we tied in? Y prime is equal to 1 over, what was it? 1 over x ln a. That's what we came up with right there. So the first part right here, what's that first statement? This right here is the definition of log. That's the definition of a logarithm right there. The second part is the definition of a logarithmic derivative. I guess you'd say is the quotient rule. That's true. So you would say y prime is equal to low, right? So what's the low function? 3x plus 2 to the low times the derivative of the high function. But to do the derivative of the high function, what do you need to use? Product. So the derivative of the first is going to be, what is it? 3/4 x to the negative 1/4 times the square root of x squared plus 1 plus x to the 3/4 times the derivative of that second one, which is 1/2 plus 1 to the negative 1/2 times 2x. That's low d high minus, we're still working on the numerator, I'm just running out of space, minus, that's low d high minus high, oh, that's a square root, not a parenthesis, right? High, and what's the derivative of the low? 5 times 3x plus 2 to the 4th times 3, all over 3x plus 2 to the 10th. So there it is. Now, could you simplify that a little bit? If you had to do anything more with this, if I asked you to do anything useful on this, what would you say?
15. 3 times 5.
3 times 5. You'd be like, yeah, I can simplify. But do you see any other, would you want to do any algebraic manipulations on that? Not really. Okay, so let's try something else. Let's try something else. No, I'm not asking you for algebra time. We're going to start at the beginning again. What's the golden rule of algebra?
You can rewrite things.
Nope. Well, what's the golden rule of algebra? Do you remember? What you do to one side, you have to do to the other. Right? What you do to one side, you have to do to the other. If you multiply one side by 5, you have to multiply the other side in the equation by 5. Okay, so if I take the natural log of one side, what do I have to do to the other? Take the natural log of the other. Does this seem like I just made it simpler? No, not really. This seems like I made it worse. Okay, what about this? Do you remember your log rules? What'd you say, Erica? Minus. That's true, right? Huh? What do you do with products? This is ln of x to the 3/4 plus. Because of log rules. Log rules. Yay, log rules.
Can't you kick out
5 ln. Oh, you can kick out a lot of things. Have I done any calculus yet? Unfortunately, you have to remember some log rules. 1/2 ln of x squared plus 1 minus, and I can't do anything to this. All I've done is apply log rules. When you divide two things inside a logarithm, that means minus. When you multiply two things in a logarithm, that means plus. Have I done any calculus yet? No. Okay, so I've just rewritten. That's all I've done. Now what should I do if I'm looking for y prime? Take the derivative. What is the derivative of ln y? What kind of differentiation do I need to use? Implicit. This is important. We are using implicit differentiation. So what do I do to the left? What does it turn into? What's the derivative of ln y?
1 over
1 over y times y prime is equal to 3/4 times 1 over x plus 1 over 2 times 1 over times 2x minus 5 times 1 over plus 2 times 3, right? Can I clean this up? Yeah, so what does this become? Y prime over y is equal to 3 over 4x plus, and that cancels right there, so it's x over x squared plus 1 minus 15. Hey, there's your 15 over 3x plus 2. What are we trying to isolate? We just want to get y prime. Okay, so what do we multiply both sides by? So y prime is equal to y times 3 over 4x plus x over x squared plus 1 minus, like having y in our derivative? No, what does y equal? What does y equal? But we know this is true, right? We know y is equal to that, right? So what does y prime now equal? X to the 3/4 times the square root of x squared plus 1 over 3x plus 2 to the times 3 over 4x plus x over minus 15 over plus 2. We have a final answer right here. This is called, what do you think this is called, this process? Amazing, yay. It's called logarithmic differentiation. Now overall, you could make a case that the first thing you did, even though it's uglier, took less time. Why is this method generally preferred though? Can someone tell me why this method is generally preferred? It's overall cleaner, and the reason it's cleaner is it's smaller steps that are easier to be more consistent with. It also works when you do this over and over again. If we call this the first line, the second line, and the third line, what line do many people just skip to? The third line. If you look at that original fraction, if with practice, can you just know that it goes from this all the way to line 3? Absolutely. And once you get there, these derivatives, taking the derivative of each piece, really straightforward. We have the derivative there, 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 and there. It's really straightforward. So you're breaking down something bigger where it's easier to make a typo into something smaller where it's less likely you're going to make a mistake. I mean, you could... so now we can differentiate both sides using what rule? We're going to implicitly differentiate, but what rule while we're implicitly differentiating? Product rule. The derivative of the first times the second plus the first. What's the derivative of ln x? 1 over x equals the derivative of the first times the second plus what? Times 1 over y, y prime. Good? What are we trying to isolate now? Y prime, right? Do you agree with that? Okay, so how do we isolate y prime? We have y prime ln x minus x over y. Y prime is equal to ln y minus y over x. What can I factor out of both sides? So you end up with y prime is equal to ln y minus y over x all over what? Ln x minus. Now at this case you would say to yourself, what would I really like to get rid of if I can? Love to replace y in terms of x. In this case it's not going to be possible. Why?
Because we don't know what y equals.
Not only do we not know what y equals, let's go back and look at the original equation here. This is like, oh man, there's only 4 symbols. There's 5 symbols of that entire equation, including the equal sign. Do you have any way of isolating y? So hard to isolate y. And even if you isolate y, is it necessarily going to be a function? If it's not a function, you have to break it apart into multiple functions. It'd be a relation. So if I asked you for the derivative on this, what is the derivative? There it is. That is the derivative right there. There's nothing else you can do at this point. Now what do? The derivative of both sides. So the derivative of the first times the second plus the first. Now we need the derivative of log base x of y.
1 over x.
No, it's not. 1 over y ln what? X equals... Oh, but then we have to multiply by something else right here. What do we have to multiply? If we did the derivative of this, what do we have to multiply on the outside? Y prime, right?
Yeah.
No, it's 1 over... No, this is wrong here. Look, if we have y equals log base a of x, the derivative of is y equals x ln a, right? So that means it would be what y, in this case, it's...
Y ln x.
Yeah, y ln x. I'm sorry, you're absolutely right. Thank you. We were right. I'm just checking, Okay, but what do we have to multiply by? Y prime is equal to... So yeah, you can get another form of this. I'm not going to finish this, but you just have to isolate y prime. I'm not going to do that out, but you're absolutely right. That's a good method. It's not quite as... It's a little bit dirtier, but it's a new method.